Hello everyone. Today we will take a look at DIY proof of concept project wireless remote data monitoring system which is published on electronicsforyou.com. Link to the project is in the description of this video. Today we are going to talk about how a remote monitoring system helps factories and farms run better by keeping an eye on things like temperature and moisture, all from a distance. The system uses tiny sensors placed around places like factories or farms to collect important information. How does this help? Exactly. These sensors gather data about how things are running, like how hot it is or how much water is in the soil. This info goes to a central computer that helps make everything work smoothly and safely. The system can transmit data over several kilometers. It helps in real-time remote monitoring. So how does it work? Let's take a look. This is a prototype. Both transmitter and receiver are shown here. At the receiver end you can see the values of temperature, humidity, light and soil displayed. The values are refreshing every 2 seconds as the display is showing the values in real time. This project is great for many people, including those who run factories or power plants and farmers who want to keep their crops healthy. It's also safe for workers in dangerous jobs where checking things by hand can be risky. Plus, people who make tech products can use this system to connect with other smart devices, and schools and researchers can use it for teaching and studying. But how to make this? You can make this with very few components. Arduino Uno or Nano boards are the brains of the system, managing data collection, controlling sensors, and handling communication. They are chosen because they are easy to use and flexible. DHT11 temperature and humidity sensor measures ambient temperature and humidity. It's used because it's cheap, fairly precise, and works well with Arduino boards. The soil moisture sensor checks how wet the soil is, which is important for farming to make sure crops get the right amount of water. The LDR measures how bright the light is, which is important for growing crops and for the conditions in places like factories. HC12 modules help send information wirelessly over long distances between the sensors and the main monitoring center. It's used because it can send data over several kilometers. Various resistors are used to make sure the circuit gets the right amount of power safely, preventing any parts from getting too much electricity and getting damaged. The SPI TFT LCD monitor shows live data from the sensors with graphics and animations, making it easy for users to understand what's happening. First of all, we will assemble the transmitter circuit and then the receiver circuit following the circuit diagram. For the transmitter circuit, arrange all the components including the Arduino board, all the sensors and the HC12 module on the breadboard. Now use jumper wires to connect these components following the circuit diagram. Similarly, for the receiver circuit, arrange all the components including the Arduino board, the TFT screen and the HC12 module on the breadboard. Now use jumper wires to connect these components following the circuit diagram. Now our circuits are assembled. Let us see the code for both the transmitter and receiver. This is the transmitter circuit code. First, include a few libraries to work with the sensors used. Define the GPIO pins of the Arduino board connected with the sensors. These functions print the light intensity, moisture level, temperature, and humidity values read by the sensors. These functions transmit the sensor values to the receiver. In the setup function, initialize the baud rates and delays. In the loop function, read the sensor values from the pins and call the functions defined above to print the values over the serial monitor and transmit the values to the receiver. This is the receiver circuit code. Define a few header files to work with the HC12 module and TFT screen. Define the model number of the TFT. Define the pin connections here. Establish the SPI connection as the TFT module used works on SPI communication protocol. These functions draw the humidity, light intensity, moisture and temperature blocks on the TFT screen. In the setup function, initialize the TFT screen and draw colored lines for each of the value blocks that will be visible on the screen. In the loop function, receive the data transmitted by the transmitter and printed over the TFT screen. Upload both the transmitter and receiver codes on the respective Arduino boards. Once the codes are uploaded, power up the circuits and you can see the values coming from the transmitter and displaying over the screen at the receiver end. Voila! It works. What did you learn? How to integrate various sensors in a single project. How to set up and manage long-distance data transmission. The importance of handling and processing data in real time. Implementing a user-friendly interface. Interested in developing your own wireless remote data monitoring system? Kindly click on the link provided in the description of this video. Do like, share and subscribe to our channel for more such DIY proof of concept videos.